It is defined a process linked to gravity, adding an additional condition to the Einstein's field equations. When that process is taken into account, the additional condition changes the trajectory that a body would follow in the curved spacetime, with respect to the established by the Standard Model of Relativity. The effect is negligible if the distortion of spacetime caused by a gravitational field does not have a significant value. The proposed hypothesis allows to mathematically calculate the discrepancy with respect to the Standard Model of Relativity. In case of being correct, would have important implications in various areas of science, and its effect would be decisive in the study of black holes or issues related to cosmology. Relativity is the best-known model for gravity. Nonetheless, there are certain issues concerning gravity that are still under discussion. For instance, singularities linked to black holes events. The proposed hypothesis has the following features. Allows to use the relativity framework to make calculations and predictions. Discrepancies with respect to the Standard Model of Relativity are negligible for weak gravitational fields. The effect of the proposed process corresponds to the effect of a force opposite to the free fall. Quantized gravity. The hypothesis proposes that there is an interrelation between spacetime distortion and the alteration of mass energy. Probabilistic approach. The proposed process is linked to a probabilistic phenomenon, where the interaction between gravitational waves with mass will alter the state of that mass. Considering expansive scenarios, the reverse process takes place, so that instead of taking energy from the physical system, it will provide energy. A physical process takes place producing alteration of mass energy. It is established an interrelation between the space-time distortion and the alteration of mass energy. The hypothesis proposes that relativity is characterized by changes of state. For instance, considering the special relativity scenario, those states correspond to different velocities between bodies, so that if a body has velocity v relative to another one which is the reference, then the body with velocity v is in state b. Meanwhile, the corresponding with the reference is in state a, and the physical properties, mass energy and spacetime vary accordingly with the alteration of the state. Energy alters the state of mass energy. The greater the kinetic energy applied to a body, the greater the amount of mass energy in the beta state. Establishing a direct relationship between the distortion of spacetime and the quantity of mass energy in the beta state. Gravitational fields alter the state of mass energy as well. Physical properties, mass energy and spacetime are affected by the gravitational field, with an interrelation between both. The alteration of the states requires energy which will produce an additional distortion of spacetime. The proposed process takes place, increasing the quantity of mass energy in the beta state the stronger the effect of the gravitational field. That process requires a contribution of energy, which will be at the expense of the velocity term of the kinetic energy, or in other words that the counterpart of the energy required will produce an additional distortion of the spacetime, giving as result a modified velocity. The graph represents free-fall velocities versus distance from the source of the gravitational field. Black lines represent the ratio between velocities and the speed of light for a body in free fall, considering the Standard Model of Relativity. Meanwhile, the red ones do represent the modified velocity divided by the speed of light, which is obtained taking into account the proposed hypothesis. Scheme showing increasing quantity of mass energy, beta state, the closer to the source of the gravitational field. Establishing a direct relationship between the distortion of spacetime and the quantity of mass energy in beta state. It is possible to obtain as well the energy between states. Concerning relativity, it is not enough the assignation of four spacetime coordinates to define the properties of the physical system. Mass energy of a body located in depends on the reference taken. The present paper suggests that there is not just three space-like dimensions and one time-like dimension, but four spatial dimensions and one time dimension. A four spatial dimensions and one time dimension will be valid for general relativity with the presence of mass energy, requiring the assignation of a reference and a referenced state. The proposed hypothesis has a probabilistic approach, being the time coordinate linked to the number of statistical trials. Each of those trials have a probability for a specific event to take place. Kinetic energy alter the state of mass energy, increasing the quantity of mass energy in beta state, which is linked to the dilation of the w coordinate. What is reduced of mass energy alpha stated will be linked to the contraction of space. The dilation of time coordinate in the same proportion of the w coordinate will restore the quantity of mass energy in alpha state, but now in a curved space-time. The kinetic energy alters the amount of mass energy, alpha state, and that value is linked to the distortion of space-time. Considering scenarios with presence of gravitational fields, it is proposed that the curvature of space-time is linked to the alteration of mass energy, so knowing the Einstein's field equations might be calculated the alteration of mass energy and in turn the energy required for that alteration to take place, which is responsible of an additional distortion of space-time. This way it is linked the curvature of space-time with the probability of events taking place. Quantum mechanics is characterized by processes where particles interact, passing from an alpha state to a beta state. The hypothesis proposes that the interaction between gravitational waves and mass energy requires a contribution of energy. It is defined a process linked to gravity where mass energy would be affected changing its physical state. Gravitational waves would interact with mass energy, part of the energy is absorbed by the process and the rest goes to the velocity term of the kinetic energy. It is added a new condition to the Einstein field equations, being a more restrictive scenario. Using this approach might be possible to quantize gravity. The proposed hypothesis allows to do mathematical calculations and predictions,